Hi everyone, my name is Yoav Elat. I'm from AWS Product Marketing, and the topic of today's webinar is serverless databases with Amazon Aurora and Amazon DynamoDB. At any point in this presentation, feel free to enter questions through the text chat, and there's a team here that is answering those questions live as you type them in. So let's start with the agenda for today. So we'll talk about serverless architectures and serverless databases more specifically. So serverless has been a very big topic in the industry in the last few years, and we'll talk about how that applies to databases. We'll give a quick overview of our AWS database services that are relevant to this discussion. Then we'll go a little bit more deeply into Amazon Aurora and Amazon DynamoDB, which are the serverless, or not just serverless, but are generally our relational and non-relational database offerings. And we'll talk about some next steps and where you can find additional information. So when we talk about serverless, you can think about it a little bit as an analogy that you can make to how you use transportation. So the oldest way is probably to own your own car, which is a little bit like owning your own data center. Or you can think of that analogy in reverse, that the old way of doing IT is when you own all of the IT assets, all the hardware and the software, and that's a little bit like owning your own car. The next step up from that was probably using managed services, where you basically host it somewhere else, or you pay someone to actually host your hardware and software for you. And that's a little bit like renting a car from, Avis or Hertz, where you rent a car and then you have it for a few days, but it's yours those entire days. Whether you're driving or not, it can sit and park somewhere, but you're still renting it even while it's parked. And then serverless is a little bit more like ride sharing using an app, because you are basically only using you're only using that asset, you're using that car while you're taking the ride. And you don't need to do any capacity planning. You don't need to do any. You don't need to pay anything when you're not riding. So we think of serverless as being a little bit more like that, where you're only using those assets, or that software and hardware while you need it, and then when you no longer need it, somebody else can use it, and you're not paying anything. So that's how we think of serverless. And if you look at the evolution of how computing evolved, then it's basically been a move towards that point for many years now. So in the past, you might have used physical machines, which you provisioned probably in your own data center, and you had to do all the capacity planning, and you had to pay and own all of those machines. So that was basically a capital investment, and you had to basically own and stick with whatever you bought for several years until the end of life of those assets. A step up from that was probably virtual machines, where basically you gained a certain amount of hardware independence, where you can move your VMs between different machines based on your actual needs. You can provision them and deprovision them when you don't need them anymore. That gave you more elasticity, more scale. So that was basically, for many people, a step up from physical machines. The step after that, you could say, was probably microservices and containers, which gave you an even higher degree of platform independence and a more dense type of deployment, where you have higher resource utilization. So you could do deployment faster, easier. There was basically more agility to the way you did IT. And we think that serverless is actually even one step up from that. So serverless has become very popular in large part because of AWS Lambda, which is basically serverless at the programming and compute layer. Today, we're going to talk about how that can fit in with serverless databases, where your database is also serverless. And the way we think about it is it's actually a very important missing piece, because if you only do serverless at the compute layer, then you still need to do some capacity planning. You still need to think about, how much database do I need? How many requests are going to come in? How many transactions am I going to read and write? You still haven't solved the problem. You haven't completely eliminated capacity planning until you have serverless at that layer as well. So we think that now with serverless databases, that's kind of a missing link, so that the whole thing is serverless. So if you use Lambda together with Aurora or DynamoDB, which we're going to talk about today, now the whole thing is serverless. We think that's a very nice way and a very good architecture to use. So why would you want serverless databases? So for a number of reasons. First of all, because it's simple and you don't need to provision hardware. I mean, that's mostly true in the cloud in general, but this actually means that you don't even need to think of what kind of hardware do I need? What kind of hardware do I want to run my database on? What instance size do I need? What kind of I/O? How much memory? You can think much less about those things because it's basically done for you. Of course, there's a server somewhere, but as far as you're concerned, you never see it. You don't need to care about it. You just pay for what you use. It's more scalable, and more importantly, it's auto-scaling. So the capacity scales up and down based on the actual needs of your application, which is very useful. And it's cost-effective because you only pay for what you use. So again, this is something that is very familiar in the cloud, that you only pay for what you use. But in this case, it's a step further because when it's not actually in use, when it's not doing any work, then it scales down, and it can even scale down all the way to 0. So if there's no database activity, as we're going to see in the next few minutes, you pay literally 0 for that database instance. So it's even more cost effective than just cloud in general. So what are the key use cases? What are the main situations where you might want to use a serverless database? So first of all, for unpredictable workloads, this is probably the most obvious one. So if you don't know exactly what database load to expect, for example, let's say that you're running a news site and suddenly there's this big headline that comes in and you suddenly see, a million people coming to read that headline on your news site. You don't know that ahead of time. You don't know when the news will break. So it would be really wasteful and expensive to plan for maximum capacity and just to expect, a high surge in traffic all the time when in fact it only happens every so often. So it would be very nice if the database behind that website would scale up when traffic is high and then scale down all the way when traffic is low. So that's when it's unpredictable. The second thing is when it's cyclical. So a classic example of that is a development or test database. So your QA people come in every day, they work all day, and they leave in the evening. And let's say that they don't work or they don't run any tests on weekends. It's not always true, but let's use this as an example. Then that workload is very cyclical. So why not just shut down the database at night, and then AWS will charge you nothing for that database at night because you're not using it. Third thing is an intermittent workload. So it's not so much that the capacity is unknown, but it's more that you don't know when that capacity will be needed. So you have a low volume blog site. Sometimes people read it, sometimes they don't. The number of readers is maybe fairly predictable, but you just don't know when they're going to come and read those articles. So if it just kind of comes and goes, that's another good example where you want a system to just automatically scale up and down to the actual needs that you have. So these are some of the key use cases. It's very important to say that not everyone has these situations with their database. So if you are just using, if you just have a very steady state database where the number of transactions is pretty consistent, then you don't need this. But if you're like a lot of people, then this really solves a lot of cases that people have. So let's talk about the offerings that we have and dive a little bit into each of these two offerings. So the first one is Amazon Aurora, which is our main offering for relational databases. So a relational database is what you would use if you store collections of data items with predefined relationships between them. They're organized as a set of tables with columns and rows. You can join tables. There's relationships between these tables. And that's good for the traditional type of application, like classic business applications, ERP, CRM, e-commerce. So that's been kind of a mainstay in the database industry for, I think, almost 50 years. A newer type of database is non-relational, where a prominent example or a prominent type of non-relational database is a key value database, which is optimized to store and retrieve key value pairs in large volumes and in milliseconds. So it avoids a lot of the overhead that you have for relational databases, which do need some amount of work in order to maintain those relationships and keep everything consistent. So with a key value database, you get a lot of performance improvements and high volume. And that's good for various type of internet scale applications, need to scale to really, huge, petabytes of information, trillions of items, and things like ad tech, gaming, IoT are good examples of that. So looking a little bit at each of these two products. So Aurora is a relational database which we built to be MySQL and Postgres compatible. So it's completely compatible with these two very popular open source databases, except that they're faster. So up to 5 times faster than MySQL and up to 3 times faster than a typical Postgres database. So basically gives you the performance and availability of commercial grade databases like the old school databases that people have been using for decades, like Oracle and Microsoft SQL Server, but much cheaper at 1/10 of the cost. So they give you basically all the performance and scalability benefits of commercial grade databases, but at a much lower price and with full compatibility with familiar open source databases. Also provides high security, so all of the security capabilities that you might be familiar with from AWS around encryption, around network isolation, around access control, all of that works with Aurora, and it's fully managed. So like a lot of services, including our database services, everything is fully managed. You don't need to provision any hardware. You don't need to take backups. You don't need to do patching, any of that. So that was true even before it was serverless, but especially you want it to be like that way when it's serverless. And then DynamoDB, our key offering for non-relational database. So that gives you performance at a higher scale. So consistent performance, single-digit millisecond response times, and at any scale you can scale it. And our customers are scaling it to enormous heights, and so are we at Amazon. We're a huge user of DynamoDB internally, and basically gives you unlimited scale. It's been serverless, and we'll talk a little bit about the subtle difference here. How was it serverless before, and how is it serverless now? So basically, with what we're talking about today, it's becoming even more serverless than it was before. So we'll talk a little bit about what we mean by that. And again, you have comprehensive security and lots of modern applications, or what we call internet scale applications. Huge websites are using DynamoDB as the foundation. Okay, so with that, let's start with Amazon Aurora, talk about that a little bit, and then talk about Amazon DynamoDB next. So let's start with relational databases. And as we've been saying, capacity management is hard. So it's a moving target. It changes over time. It's sometimes unpredictable. And then the problem when it's unpredictable is that you as the IT manager or as the developer trying to optimize your database and give it the right capacity, you have to, first of all, you need to do fleet monitoring. So you need to scale up your database before you need it. You don't want your users to get a bad response time. So if you know in advance that there's going to be a surge in database traffic, then you want to, or website traffic or whatever it is, then you need to plan for it before it's needed, which is kind of hard if it's unpredictable. And you need to predict it sometimes months or years into the future, especially if you're not in the cloud. Now you need to buy all that hardware. So that would become pretty bad. You need a manual effort to spin up and spin down those databases when it's intermittent. So even if you know it in advance, if you know that the database traffic will change every hour, you need to sit there, or you need to find some way to automate that spinning up and spinning down of those databases. It's also expensive because you need all of that extra hardware and software in order to deal with those surges. So if you know you're going to need a bigger instance for your database, then you have to have a secondary, basically a secondary fleet of databases which are bigger that will be ready to take over from the ones you're using right now. And you need your application to do the cutover to go from using your existing database that you're running now to some other instance. It might require application code changes, and it could cause all kinds of problems, like when you don't do the cutover properly and you're writing from your old, you're writing to your old database and to your new database. If you're not careful, you can get into all kinds of bad situations. So it's not an easy problem to solve. The way we solved it with Aurora Serverless, which was released in the summer of 2018, so a few months ago as of now, is that your application basically doesn't talk directly to the database, but it talks to what we call request routers, which basically become the endpoint that your application is talking to. And you can see that in the diagram. And like we said earlier, the serverless database or serverless Aurora database will start up, it'll shut down, and it'll scale up and down automatically based on the actual number of transactions that it's getting from the application. And it does that very quickly with no application impact and when it's doing that scaling. So the way it works is your application talks to one of these request routers, and behind them, there's a whole fleet of databases that are ready for use. So basically, and you can see that in the blue rectangle in the middle of the diagram. So basically, what it does is it calls on a warm pool of instances, which you see on the right, which are basically instances of different sizes. So what we call different instance types in AWS, and you will have a whole fleet which are basically ready to attach to your data as soon as you need to scale up or scale down. So since those instances are warm and they're already initiated, they're already ready to run, then the scaling up and scaling down is very quick. It's much faster than what it would take you, like if you had to go and start and boot up that instance from scratch. And even when you shut down your database, we can still go and use one of those instances if your database needs to start up again. So usually scaling from one instance size to the next is very quick. It's less than a second. And scaling from complete zero, like if your database didn't have any transactions and we shut it down completely, you can scale using that warm pool of instances. You can restart that in something around 30 seconds. So for some people, that's great. If your database hasn't been used, then you want to shut it down, and then the next time that someone comes along and tries to access that database, it'll take up to 30 seconds, which I think for many applications, that's fine, especially if it's a development or test system. I think that would be a very good example. In some cases, it's not good enough. So if you have a production website and people are coming to your website and your database is behind the website, the first guy that comes along after the break will have to wait up to 30 seconds. So they click and they wait 30 seconds. That's not a good experience. So you can specify that you don't want us to shut it down all the way to zero. So that's another option. Or you can keep a small instance around so that it'll kind of hold for the first few people that come back, and then you'll scale up to a bigger instance size after a few seconds. So there's different ways to do it, but just keep in mind that you can scale up, scale down, scale all the way down to zero. And you really don't need to do anything. Everything is happening behind the scenes. Your application is only talking to this request router, to this endpoint. Everything else is managed by Aurora Serverless in the background. The price, and we'll talk a little bit about pricing in a moment, but basically the key thing is that you pay per second with a 1 minute minimum. So as soon as we start using one of these instances, you will pay the per second price for that instance while it's running with that minimum. And when it shuts down or when we move to a different instance size, then you'll pay for that other instance size. So you literally pay for what you use. A comment about how we do the scaling is that generally we try to scale up pretty quickly when the load increases. And we scale down a little bit more gradually when the load starts to decrease. So it's always a set of steps, obviously, because there are certain instance sizes. Each of them has a certain number of CPU cores and memory and so on. But so that's why you see the blue line, which is a set of steps. But we try to take it easy a little bit with scaling down, just in case it's a temporary drop and we don't want to scale down too fast. But scaling up quickly is obviously very important. So if you see actual transactions coming in, you want to scale up right away to be able to serve those transactions and keep some of these metrics where they need to be in terms of response time. So that's how it works in terms of scaling up and down. So let's do a brief overview of what's available now. So first of all, in terms of compliance, we've gotten certifications for, some of these are probably very familiar for you depending on your industry. Aurora Serverless got these certifications as a sort of update to the existing certification that we had for Aurora itself, which has been around for a few years. We're now up to 14 regions. So these are 9 regions that were added in the last few months. The original release was for 5 regions, including US East and Ireland and a few other ones. So these are the ones that we basically completed. So now we're at up to 14 regions for Aurora Serverless. So it's basically, it should be available in any region that you might need. It's available today for the MySQL edition of Aurora that's compatible with the MySQL 5.6 database. And we started a preview for the Postgres edition. So you can sign up for that preview if you go to the Aurora website, RDS/Aurora. You'll see that there's a link to sign up for the preview if you'd like to try the Postgres edition. Another thing that we recently added, which was added in, I believe, in the beginning of November 2018, was a REST Data API. And let me talk a little bit about that now. So the way that many applications work is that they find it much easier to access a database through HTTP. And with Aurora Serverless, that's actually a requirement for some of them because you sometimes don't have the classic huge application running on top of a database, which you would have with a typical relational database. In some cases, like some of the examples that you have here, like if you look at the bottom right, so things like Lambda applications which make Lambda calls, or lightweight applications like IoT devices sending updates through the network, or a mobile app, if you're written it using our AppSync synchronization technology. Sometimes you just want to do a quick function that just goes, accesses the database, writes something, and then shuts down. And it doesn't really need a long-lived connection to the database, and it definitely, you don't want to install JDBC drivers and things like that on the application side. So what you just want to do is to have a simple data API based on HTTP where you just go, you write something or read something and shut down right away. So for these types of application, we created the data API, and that's available now in preview as I'm speaking now, should be out as GA, hopefully soon. And this is exactly what it does. So basically you have a simple HTTP interface. The public endpoint for the Aurora Serverless database is accessible for anywhere, of course, subject to the right security. You don't need to do any client configuration, so there's no drivers to install on the application side. You definitely don't want to install any drivers on your IoT device or on your mobile app or anything like that. And you don't need to keep any persistent connections. It's just a simple web service that you call and then you're done. So you can make millions of calls like this and it'll be written into the Aurora Serverless database. And we're also planning to bring this to any Aurora database. So even if it wasn't serverless, you'll find that available pretty soon. So last thing about Aurora Serverless, Aurora in this presentation is about pricing. So the database capacity is measured in what we call Aurora capacity units. So that's different from how you pay for a typical Aurora database instance. So typically for instances, you pay for how much CPU, how many CPU cores they have, how much memory they have, what kind of IO capacity they have. But you don't want to price it that way for a serverless database, right? You don't want to price according to memory and CPUs because you don't want to talk about, the whole point of serverless is you want to price by, not by hardware thing, by hardware metrics. So an ACU is of course based on some kind of hardware metric, but for you as a user, it's a more kind of abstract concept that has a sort of a measure of how many resources you're using without having to mess too much with what exactly they mean and how much memory that represents and how many CPUs it has. So an ACU is the fundamental pricing metric for an Aurora Serverless database. And as an example, if you're running in the US East region, then you would pay 6 cents per ACU hour. And there's a bunch of pricing examples on the website which you can go and read on the serverless page. It kind of gives you a feel for how much you would pay if you're using ACU pricing. And it's the main thing that you'll notice is that in those examples is that you're paying only for what you use. So your database might run for 5 minutes, you're consuming a few ACUs, and then meaning that there's a certain amount of hardware that's being used to run your database. And if your database suddenly shuts down, or if it's meaning that there's no traffic, or if it goes down to a smaller instance size, it would consume less ACUs and you would pay less. And again, it's being priced by the second. Okay, and last thing about Aurora is what some of our customers are saying. I won't read out all the quotes here, but you can see them for yourself. There are some nice examples here, such as the one from NTT Docomo, which is the third one on the right, which is a huge Japanese mobile phone company. And they found it very useful to reduce their operational costs by using Aurora Serverless. So it's a really good fit for a telecom company, for example, when they can't exactly predict a lot of costs that they have based on what their users are actually doing. They will need to scale their databases up and down. So they found Aurora Serverless to be a really good example of that. Okay, so with that, let's jump into DynamoDB, where you'll see very, very similar concepts to what we saw with Aurora Serverless. So DynamoDB is also taking serverless one step further than it was before. So it always was serverless in the sense that you didn't really have to deal with hardware or to really choose a lot of, you didn't really have to deal with sizes and scaling. That was always done behind the scenes in DynamoDB. There were no servers to manage, there was no administration of servers, and they always had Lambda integration. So you could always make a Lambda call that will read and write from a DynamoDB database. So that's always been the case. But there was still some element of capacity planning that you needed to, well, you needed to think about how much, about how your application would scale. And there was some element of, it did take some time for DynamoDB to catch up with the kind of classic provisioned mode where you had to provision it yourself, that while, so when the traffic went up, it did take some time until DynamoDB actually saw that scaling up is needed and took the next step. So there was a certain case where you were basically dissatisfied, or the user was dissatisfied when capacity has not caught up yet to the size that is needed, or waste when you're still running on a bigger instance size, where when it's, or using where you basically scale too much and you're basically wasting resources and you're paying for something that you don't truly need. So that's a problem that that was solved with a recent announcement of what's called DynamoDB On-Demand. That was a launch at reInvent 2018, November 2018, when there's much more granular and quicker scaling to the actual capacity that you need for your DynamoDB database. So as your databases, or as your application ramps usage up and down, your database will also ramp up and down. So you can start at 0, and when DynamoDB sees that there is traffic, it will start scaling up, and it will do that very quickly within milliseconds. So there's basically the same type of, it's basically instant. It's the same type of latency and the same SLA commitment, and of course the same security that you're used to with DynamoDB in general. And there's no limit to how much you can scale. So DynamoDB is incredibly scalable, and you can scale up pretty much either if you scale up to a size that was previously provisioned by DynamoDB, then it will be completely instant. Everything is available there. You only pay for it as you're using it, and it can also increase the size, increase the resources, the number of instances that are serving your workload, and that happens almost as fast. So there's basically no limit to how much you can scale your DynamoDB usage with DynamoDB On-Demand. The pricing is a little bit different, and we'll talk about pricing in a moment about how DynamoDB On-Demand is priced. So, like I said, you can, unlike in provision mode, you can basically scale pretty much continuously and very, very quickly compared to what you would do in the classic DynamoDB provision mode. So some of the advantages is you can start at 0. You don't need to set a minimum anymore. So capacity it basically scales up and down all the way to 0. You can see on the graph on the right side that it can literally be 0 for a while, and then when more traffic comes in, it'll go back up again. And it can go beyond the maximum consumption, which is what I mentioned in the previous slide, is that even if it passes the previous maximum, it will provision more so that you can basically access the database with unlimited scalability. And everything is managed for you. You don't really need to do anything. So in terms of pricing, it's priced differently from what you are used to with DynamoDB. So pricing is by requests. So basically the way you pay is by the number of read and write requests that you make to your DynamoDB database. You pay per million of those requests. So as you can see in these examples, again from the US East region, you would pay a certain price for 1 million write requests and a certain price for 1 million read requests. If you're using DynamoDB Global Tables, which is an optional feature that replicates your data very fast between AWS regions, then it's slightly more expensive because that's kind of an extra benefit feature. So that's a little bit more expensive than the regular write requests per million writes. So that's about it. I hope you find both of these serverless databases useful. You can get started by looking at our websites for Aurora Serverless and for DynamoDB On-Demand. They're both at awsamazon.com, and hope you can find these useful for creating completely unlimited scalable applications. So thanks very much. I want to remind everyone that you can still continue to send in questions, and we'll still be here for a few minutes to answer your questions. So thanks very much.